Hello and welcome to our presentation. My name is Stefan Astinsky and I'm a professor at the Division of Digital Learning and the PI for this project. With me I have Katie Tian, who is a postdoc in the project. We will present our Digital Futures demonstrator project called Semi-Automated Math Tutoring. In the team, we also have Professor Olof Engvall and Malin Jansson, who is a researcher and also KTH project leader of a project called Maths Coach Online. We will tell you more about in a minute. One-to-one tutoring, where every student has their own tutor, is a very effective teaching method, but the key challenge is how to scale up one-to-one tutoring. In our research group, we have made significant contributions to research on human one-to-one tutoring in online settings, especially in math. At the same time, we've seen major developments of intelligent tutoring systems where tutoring in some settings can be as efficient or even more efficient than human tutoring. Olof and his colleagues have made important contributions to this field, investigating in particular computer-animated tutors and social robots for learning. This project aims to develop and study a demonstrator of semi-automated online math tutoring by combining a human approach and automated tutoring. We believe that human tutors will continue to be important to provide social support to students and also to handle parts of conversations where automated tutors do not perform well. The suggestions are based on natural language processing analysis with pre-trained transformer language models based on machine learning. In this way, we can select or generate relevant tutor responses to the students' queries based on earlier similar interactions. We are currently developing an automated tutor that will give suggestions to what the human tutor could write. The tutor can then decide if she wants to use any of the suggestions from the automated tutor, or if she wants to adapt one of the suggestions or simply discard them. Based on these findings, we can train the model to be even better. The research setting is Maths Coach Online. In this setting, we're offering one-to-one tutoring by teacher students to K-12 students and have conducted more than 70,000 conversations. The project is conducted together with Linköping University and Chalmers University of Technology. Maths Coach is open Monday to Thursday every evening between 5 and 8. It's free. There are up to 12 tutors available every evening at these different universities, and most of the tutors are teacher students in mathematics. So an important part of this demonstrator project is to investigate how semi-automation can support learning and help scale up individual student tutoring. We believe that human tutors are essential in the Maths Coach Online setting, but parts of the tutoring could be automated with a digital tutors to increase the time students reflect on the learning, but also decrease the load on the human coaches. This is an example of how Maths Coach Online looks. There is a chat and possibility to draw. There's also a tutor interface where there's a queue of K-12 students and where tutors can interact with each other. Each tutor often works with several students at the same time in different windows.
So with our project, what we want to be able to do is have an automated tutor, which is going to be the LLM, send suggestions to our human tutor or our math coach, which they will then decide whether or not to give to the students, and the student will then give their responses or send their questions, and we'll just keep having this loop going back and forth as we collect more data and more information about how to fine-tune our model. So we want to automatically generate suggested tutor responses using our LLM, and we want to make sure that we are using rules for a pedagogical strategy, and we want to make sure that the type of utterances are appropriate at different stages of the interaction. And we also want to build a database of previous interactions between the students and human tutors. So we want to also get feedback from the coaches and from the students. So we want to have reinforcement learning with human feedback, or RLHF. And all of that information is also very valuable for fine-tuning. So there are several ways that we can use to accomplish our goals. One way that we're thinking about right now is to have our large language model. And as we mentioned, we would use our large language model to provide suggestions to our coaches. So for example, here we have some Swedish suggestions about how to solve a problem. And the coach can then decide whether or not they want to move forward with the suggestions or if they want to make their own suggestion. And they can also maybe manually edit the suggestions before deciding to send that to the students. And what we're also going to do is, once that has been sent to the student, we will also receive feedback that we can then send back to our LLM. And what we'll also be able to do with this information is, since the coach will be deciding whether or not to move forward with an example or not, and they might make edits, we will have more data that we can use for reinforcement learning with human fine-tuning, and we can leverage that data then for further fine-tuning of the LLM. So what we also need to do is to make sure that the NLP programming is able to tune to the math coach and make sure that it is fine-tuned on existing math coach data. We also need to make sure that it suggests utterances based on the Eliav or the student utterances, and we can keep updating it based on fine-tuning. And we also want to have a GUI that will allow the tutor to select and modify or send utterances and give downvotes, and that kind of information is really valuable for fine-tuning. So what is the current technical status? Well, we have currently tried 5 different open source LLMs, and the pace of this space has been moving very quickly. So we have tried Llama and Alpaca, Vicuna, Falcon, and Llama 2, and they have all been at the top of the leaderboard at some point or another. Llama in particular is really where things kicked off with the Meta open source large language model. So our current status is we are leveraging Meta's open source Llama 2 model, which is currently ranking top in the leaderboards. And we wanted to go with Llama 2 because it has really good and strong performance, but we can still keep it at a relatively smaller size. So previously we were looking into the 40 billion parameter Falcon model, and that is just a bit too heavy and kind of cumbersome for us to run. So we are shifting toward 13 billion parameter Llama 2 model. And what we have done so far as well is that we have done some fine-tuning using previous math coach data, and we've also translated some open source data sets to Swedish for further fine-tuning to make sure that the Llama 2 model can more consistently receive and respond messages in Swedish. And we have been working with a GPU cluster for AI ML training, but unfortunately, this cluster does not allow public API calls, so we will be moving forward with a cloud computing platform to deploy and host our model, and we are thinking about using GCP. So for the next steps, we also plan to start experimenting with the language model, hosting it on Google Cloud Platform, GCP, as we mentioned. And it's still a question of how we will handle some of the math, as the model often gives wrong responses for math equations. However, we also see great potential in suggesting open questions to support the process of learning, like getting students to think and reflect deeply about the question. And we will also experiment and do an early pilot to see what else needs to be improved, to see if we can get the model to, for example, remember longer conversational turns. So with regard to the evaluation methodology of this project, we're still in the early stages, but what we would like to do is first conduct a pilot study and conduct interviews or observations of the math tutors to learn what works well and what we need to improve. We also will conduct thematic and comparative analyses of semi-automated tutor interactions and human-to-human interactions, so this will help us to understand how these differ and the benefits and challenges of semi-automated math tutoring. And as we move forward at a later stage, we plan to conduct a randomized control trial to study the effects of perceived learning and social presence. And what we want to do is randomly assign students into a treatment group where tutoring is semi-automated versus to a control group where we have only human tutoring. So we're also thinking about more objective measures that we can use, like examples like conversation length, time, turn taking, and also content analyses of the indicators of reflection of learning. And we're really hoping that this is something that students will continue to keep using. Okay, so thank you so much for listening. With our project, we really hope to contribute to research on semi-automated tutoring, which is a scientific area that has received relatively limited attention. So this project will be an important demonstrator of what semi-automation would look like without losing the human touch of tutoring. Again, thanks for listening, and if you have any questions, feel free to send us a message.